My name is Jack Sims. I was a high school art teacher. Moved to the desert, built a studio. My midlife crisis sports car is this. First sort of documented damage to my knee was in middle school. I developed a disease of the growing end of the bone. So that, coupled with just being very active in sports, my left knee started acting up. By my early 60s, it was becoming a problem where some days it was hard to walk around without limping on it. When I went to the orthopedic surgeon and they talked about knee replacements, I was actually thrilled that there was a possible way of fixing it once and for all and alleviate it.
There are approximately 1 million knee replacement surgery procedures performed in this country every year. It's predicted that 50% of adults will have advanced knee arthritis requiring knee arthroplasty at some point in their lifetime, and that number of total joint replacements performed in this country will grow to almost 3.5 million over the next decade. While total knee replacement is considered one of the most successful procedures done, there are some challenges that we still need to solve. One is that somewhere between 10 and 20% of patients still have problems after surgery. But we have a hard time measuring those outcomes. We have objective measures, how patients feel, and then we have traditionally seen patients in the clinic. But that's twice, sometimes 3 times after surgery over the course of a year. What we've never had before is the ability to track how people do over time on a continuous basis.
My recovery was longer than other people's recovery. I didn't really feel like I had a partner in that.
We really want to be studying those people who are at risk for having a poor outcome. The UCSF Human Performance Center can evaluate patients. We can reserve the resources like the 3D gait biomechanics lab for those individuals that most need it. However, access to that is quite limited. Generally, only people who enroll in research studies get to experience 3D biomechanics testing. So our standard equipment in our laboratory is motion capture data. We put markers on specific areas on people's body, and then as they walk within the laboratory, the cameras can track those markers. We create a 3D model which tells us exactly where the joint locations are. Measuring these key variables in the laboratory is great. However, it's not enough. What we really need to know is what people are doing in the real world.
We're not the first looking at the opportunity to use sensors to recreate a gait lab-like experience where we can start tracking how people do, but not have them come back into an academic environment or lab environment to do so. I actually had the opportunity to attend TED, and Ivan was showcasing how the Google Jacquard sensor could be used to interface with their environment. I went to Ivan to mention that I've been doing this research and I've been very disappointed with the results of using commercially available wearable sensors to track patients in the gait lab. And he said, there's a reason for that. You're simply collecting the wrong data, but we can help you with that.
My first reaction was, we can do so much more with modern artificial intelligence techniques and machine learning techniques. Solving problems, such as the one we're working on with Dr. Bini, requires to have a broad variety of perspectives and broad variety of expertise. And I'm leading an innovation group at the Advanced Technology and Projects Division in Google, also known as ATAP. Our team is highly interdisciplinary. We have hardware engineers, we have signal processing experts, we have machine learning experts, and we have interaction designers. And by working together, we can approach this problem holistically. The modern methods of artificial intelligence, particularly in real-time and on-device machine intelligence, which allows to run very complex machine learning models which understand human motions on very inexpensive and very easily accessible computing hardware, such as the one we're using in a Google Jacquard tag. Google Jacquard tag is a small computing module which is designed to go anywhere where you want to put computing in.
The goal of this early R&D project is to see if we can replicate the results of the Git lab using the Google Jacquard tags. If we can do this, this means that we can replicate the same type of analysis in the lab outside in the real world.
So one of the big technical challenges here is how can we replicate the output of the UCSF GitLab analysis system with the Google Jacquard tag. So to achieve that, we use our custom neural network architecture. This allows us to take our raw time series data and actually be able to estimate directly from this in blue what the knee angular velocity could be.
What the AI team at ATAP was able to do is match our 3D biomechanics data to within 1 degree throughout the entire gait profile. I didn't really think that was going to be possible.
One of the key things that we've learned is that the single sensor alone, we are able to accurately replicate the output for some key variables like knee angular velocity.
If we are successful, these techniques will have massive impact on how people recover after complex operations, particularly with orthopedic environment.
This idea of collecting data real time, 24/7 during recovery phase, and using that information to improve the recovery process, we're on the cusp of a revolution about how we think about patient care.